Everyone, how is everyone? Srinivasan sir, how are you? Good evening, good morning. Are you there? Uh, Srinivasan sir, mic is not working. Working. Okay. Yeah. So let us. We will go through the collab. We will go through the slides. I think till now slides are not uploaded in the portal. So we'll see the slides also. There are 19 slides hardly. So we'll go through the slides once, and then we'll go through the collabs as we discussed. We'll give a pause on whatever the codes are there, and you can take your screenshot. Yeah. My video feed is on. So we can take screenshot, and after you can take screenshot, and after that you can we'll see the activity question solution, and we'll see the practice question solution, and we can discuss anything also. Hmm? So, guys, any of you got invitation for the campus visit till now? Is there any uh, have it like that? You can let us know. We are planning for the campus visit of for you. Don't know whether till now you guys got invitation or not, and how many of you are from Chennai. So there's a tentative visit on I think that's March. Anyone got have any information about that? You can tell us in the chat box. Yeah, I don't know. I think maybe the Chennai for the first time the Chennai people be joining us, the students from Chennai and surrounding region. Anyway, so if nobody has received any information, you should wait for the the things to materialize and everything. Yeah. So anyway, let's begin. We have the support vector machine in week 8, and so study about the implementing support vector machines for classification. If there is the course team or the faculty is the Appendix for the slides also, you can check that there are many important slides on MLP appendices after the slides. As the slides get over, those are mostly useful when you are studying NLP and all, but I mean not very much required for NLP. That is why they were not audited. But you can get them, please. And they are not important for your exam and purpose, but they may be recorded in the email, as well as you can them for your own personal study. Okay. So SVMs are basically supervised learning methods, which are used for classification, regression, etc. So they are set of supervised learning methods. Okay, and they construct a hyperplane or set of hyperplanes in a infinite dimensional space, which are used for classification, regression, etc. So two things: they are supervised learning methods, and they construct a hyperplane or a set of hyperplanes in a high definition or a high dimension or infinite dimensional space. And we have three methods for SVM in sklearn. So one is SPC, new SPC, another is one, the linear SPC. Okay. So how do they work? So SBC and new SPC are similar, but they accept any some different sets of parameters. The implementation is based on libSVM. Okay. SVM library is the main base of the implementation for SVM and SBC and new SVM. On other hand, for linear SBC, what we have is a faster implementation of linear SVM with only linear kernel. And just a minute. Here we have the implementation is based on linear. So the support vector machines, what have we learned? That they are a set of supervised learning methods which are used for classification, regression, etc. They construct a hyperplane or a set of hyperplanes. And we have three methods of implementing SVM. One is SVC, one is new SVC, another is just a minute. Huh? So one is SVC, one is new SVC, and another is the linear SVC. So among these three, SVC and linear SVC are similar, but they accept different set of parameters. They are implemented based on libSVM and linear SVC on the other hand. They have a faster implementation and with only based on linear kernel, and the implementation is based on linear only. Okay. Then what we have is about training data. Sir has talked about that. You can see that array X, if it holds the training samples, then we have a shape, you can say in samples and in underscore features. And array Y, which holds the class labels that can be strings or integers. So we have integers 0, 1, etc. Now the question is how to implement this. The first step is to instantiate an SPC classifier. So how do we instantiate SPC? So from sklearn.svm, we import SVC. Okay? And then SVC underscore classifier is defined as SVC. Then call the fit method on this classifier object with a training feature matrix and a label vector as argument. So yeah, we model training vector with the feature matrix X train and label vector Y train. So how do we classify? We do a fit transform. We do a fitting, not transform. We do a fitting of SVC underscore classifier dot fit. So basically, we import SVC and then we do a fit on that. Okay. So we just import from sklearn.svm. We import SVC. Then we define a variable SVC underscore classifier. Then we train the model. The feature matrix is X train. The label vector is Y train, and we fit the SVC classifier on those data. Okay. So this was how to perform, how to implement SVC. Now, how to perform regularization in SVC. Okay. So how do we do that? We have some regularization parameters. C. Okay, C is a float value, and the default value is C equals to 1. Okay, C equals to 1 is our default value. So C is our regularization parameter. It has a float value. Float value is 1.0. The regularization parameters are always positive, and it has a the regularization parameter is inversely proportional to the strength of regularization. So they can ask you that what is the relation between the regularization parameter and the and the strength of regularization. Okay, so you can say that they are inversely proportional to each. And how to specify kernel type, and these things sir have taught. Okay, what are the required topics? So kernels can be linear, polynomial, RBF, sigmoid. These are the types of kernels can be obtained in SVM. We have 5 types of kernels. One is linear, one is polynomial, and then one is point, pre-computed, and RBF. And generally, the default value is RBF only, but we can use other 4 as well. Okay. And if we are using polynomial, then obviously we have to say what is the degree of that polynomial, which again, as we know, is any integer value. And if kernel is callable, then we can use that to pre-compute the kernel map. Okay. So 2 things. What kind of kernels can be used? Can use 5 types of kernel. If you do not specify, then the default value is kernel is equals to RBF. If not, then you can define linear, polynomial, sigmoid, pre-computed, etc. Okay. If it is polynomial, then you have to set the degree value, which is any integer. And if it is callable, then it is used to pre-compute the have to pre-compute the then if kernel is equals to callable, then it is given. It is then we can use it to pre-compute the kernel map. Okay. So 5 types of kernel are possible. The default is RDA. And how to set the other values? How to set the other kernels, RDA, poly, and sigmoid, so that we can use by gamma. Okay. So we have 3 types of gamma values. So one can be scale. For scale, the gamma is equals to the 1 by number of features into the variance. Then we have the auto gamma value. So for that, it is equals to 1 by number of. And if we take a float value of gamma, that also is possible. So generally, the default value is, I think, scale. It will be scale. Scale is equals to 1 by number of features into x var. Okay, that is the variance of that. And if it is polynomial or sigmoid, then we can set coef0, which gives an integer value. And once the classifier is fit on the training data, there are a few attributes which reveal the details of these support vectors. So once we have the classifier fit on the training data, then we have a few attributes which reveal the details of these support vectors. So first line, we import SVC from scalar.svm. Then again, we define SVC, so classifier equals to SVC. And after that, we put another variable CLF to be equals to SVC underscore classifier, which is defined in the line number 2, dot fit, which is a fitting, we are fitting with what? X train and Y train, of course. And now if we try to view the indices of this, we have CLF dot support underscore that we can put. And if you want to view these support vectors only, then you can just say CLF dot support underscore vectors underscore. So basically, if you want to view the indices, then you have CLF dot support underscore. If you want to view the complete support vectors, then you can put CLF dot support underscore vectors underscore. And if you want to view the number of support vectors, then we have CLF dot in underscore support underscore. Okay. So these are the ways to view the support vectors. So this was SVC. And how to now implement a new SVC? Okay. So new SVC, again, similarly, we instantiate. How? Now from, again, the same place, same library, we import new SVC from scalar.svm, and we define a variable new SVC dot underscore classifier to be equals to new SVC. So at first we did for SVC, now we are doing for new SVC. Okay. So then we call the fit method, of course, as we have done for SVC as well. We call the fit method on new SVC classifier object with training feature matrix and level vector as the argument. So how do we do that? Obviously, again, we know that we can say new SPC underscore classifier dot fit. Then we put inside bracket, inside first bracket, you can see the round braces. We can put X train and Y train. Okay. So basically, how do we fit it? So for SVC as well as new SVC, the steps are followed. You first import it from scalar.svm. You import SVC or linear. Then you define as new SVC classifier or SVC equals the SVC or new SVC. And after that, the next target first is importing, then defining. Then what you do is that you apply the fit method on this classifier. Okay. So what is our and what are the arguments for this? So one is X train, which is the training feature matrix. Another is Y train, which is a level. Okay. So both for new SVC and SVC fits are similar. And what is the significance of new? So if we put C in SVC, then instead of that, the new is introduced. Control the number of support vectors and margin errors. So why is new required? New is required control the number of support vectors and to control the margin errors. and it is an upper bound, upper bound and lower. It gives the upper bound and lower bound. So upper bound for the margin errors and lower bound for the support vector, okay, which actually resides between 0 to 1, where 1 is in closed boundary and 0 is in open bound. Okay, so it can be 0 as well. Sorry, it can so it cannot be 0, but it can be 1. Okay, so 1 is taken. So the upper bound on the fraction of margin error, that is the new, and the lower bound of the fraction of support vector is also. And the new value is, of course, open space, open bracket, bracket open, 0, comma, 1, then close bracket, okay, close brace. So close boundary. And the default value of new is equals to 0.5, which is half between 0 and 1. And other parameters are same as SBC. So the only change in SBC and new SBC is the parameter new. Okay, new is introduced to control the number of support vectors and to control the margin errors. And new gives an upper bound on the fraction of errors and a lower bound on the support vector. Okay, and what is the general value of new? The default value of that becomes equals to 0.5. And what is the maximum and minimum value? So maximum value is maximum value can be 1. Okay, stop, and the lower value can be just not touching 0, but a little more than 0. Okay, so 0 to 1 is the 0 is in open boundary and 1 is in closed boundary, but the default value is equals to 0.5. The other parameters of new SBC will be similar as that of SBC. And then other thing is remaining, what is linear SBC? So how do we implement linear SBC? Again, the same step. We have to instantiate linear SBC. Okay. So from scalar.svm, we import linear SBC and then we define it, the object. So, and then we call the method, each method on the SBC classifier with the feature matrix train and label vector y train. Okay. So if we train the model with the feature matrix X string and the label matrix label vector Y train, then what we have is linear SBC underscore classifier dot fit, that is equal of X string and Y train. Okay. So basically what it means for us is that for linear SBC, the SBC, new SBC, all three, you can actually the process is to implement. Okay, first step is to import it from the scalar.svm library. Then we define the SBC classifier object. Okay, that can be SBC, new SBC. If it is new SBC, then new SBC classifier. If it is SBC, then SBC classifier. If it is linear SBC, then linear SBC underscore classifier equals to linear SBC or SBC or new SBC. Then that we define. And then what is the argument for that when we are fitting? So then after that we are fitting it linear SBC underscore classifier dot fit or SBC dot underscore classifier dot fit or new SBC underscore classifier dot fit. Then what is happening as an argument? The argument we give as X train and Y train. Okay, so that is our main format of doing the of going in the same way. Okay. Apart from that, we have the advantages and disadvantages. Okay, just give me one moment. Hmm. Now we have advantages of linear SPC. Okay, how do we define the advantages of the linear SPC? We can see that we have, as we can know, that we have the more flexibility, right, in the choice of penalties and loss function, because it is explained in terms of more than that, it is feels better to large number of samples. The great advantage of linear. If you have a large number of values in the data set, then it can scale better compared to other algorithms, and it supports and sparse as well. Okay. So it has more flexibility, scales better, and it supports different types of input. That is the main classification, main advantage of linear SPC. Okay, so that we have to remember. And apart from that, what we can see is that there can be some more advantages, and yeah, but those are not mentioned. It's okay, fine. So you can see that it supports both the dense and sparse input and has more flexibility, and it scales better if we have a large number of inputs. So those are our advantages. One is flexibility, another is better scaling and supporting both dense and sparse input to both types of. Okay. How to provide penalty? So penalty can be L1, L2, and those are the only two types of penalties which are supported in linear SPC. So mostly we are talking, as you have seen, that we are talking about linear SPC only. Okay. So you can talk about SBC or new SPC or linear SPC. Here we have talked about linear SPC mostly. So here the penalty is that L1 adds a L1 penalty term. L2 if penalty equals to L2, then L2 adds a L2 penalty term. Okay. L1 makes coefficient vectors which are sparse matrix. How do we do that? So that we have the default value, the linear SBC classifier to be equals to linear SBC penalties. So the L is our L2 is our default penalty parameter. So what did we learn? We have learned a few things. So one is that how to implement these things. Okay, how to implement the SBC algorithm. So we have SBC, new SBC, linear SBC. Okay. So how do you implement that? First, you import SBC from sklearn.sdm import SBC. Then you write that SBC.classifier equals to your SBC or new SBC or whatever you are planning that object. Okay, that object you define. And after that, we fit the method on our data set. And what are the arguments required? We require the arguments string and ytrain. Okay. After that, what have we learned? We have learned that what are the advantages of SBC? Sorry, linear SBC. We have learned that it works for both both types of data input. Okay, the sparse and dense data inputs. And it scales better to a large number of large number of inputs available, and has more flexibility in the choice of penalty and loss. Okay. Now, the next thing which we have learned is what are the penalties. We know that the penalty can be, the penalties can be our, what do you say? It can be L1 and L2, whereas L1 leads to be a sparse matrix, gives us a sparse matrix, penalty equals to L1, but penalty equals to L2 is our default value. Okay. And L1 leads to coefficient vectors, which are sparse matrix, and L2 gives us the default parameter, default value of a penalty. Okay. Now, now the next slide, sir has talked about how loss functions. Okay. So how do we choose the loss functions in linear SPC? We have loss parameter, which can be hinge loss, which can be squared hinge loss, etc. Okay. So only two types of loss functions are available. Either it is hinge loss or it is squared hinge loss. Generally, it is squared hinge only. Okay. Hinge gives us the standard SDM loss, and squared hinge gives us the square of the hinge. Okay. Generally, we calculate the squared hinge only. So what are the if we repeat again, we have studied SBC, new SBC, linear SBC. Okay. And we have learned their implementation, which are similar for all the three cases. We have learned what are the advantages of linear SBC, what are the penalties of linear SBC. So we know that we have for linear SBC, if we have a parameter to be if we have the penalty by default it will be L2, and for the kernel it will be RBF. Okay. And if we are defining the kernel to be poly, then you have to polynomial. Then you have to define the degree of the polynomial, which is an integer. And if you have a loss function, how do you, what is the loss function? What are the loss functions possible? So either it is hinge or it is squared hinge. Okay. And if you have a default parameter, if you put the default parameter, then the default parameter is loss equals to squared hinge. Okay. So those are our cases. Huh. So if some combination is not supported, then we can put penalty equals to L1 and loss equals to hinge. Some more parameters are there. So C is a regularization parameter, which can be a float value. And dual, what is dual? Dual is to how to select the algorithm to either solve the dual or primal optimization problem. I have to check what is this. So when n number of samples is greater than number of features, then we can set dual to be equals to false. So there are some other parameters as well. There can be C, there can be dual, there can be fit intercept, okay, which calculates obviously the intercept of the fitting model, okay, which we have fitted. The intercept of that is calculated with fit intercept. Other than this, we have C and dual. Now, the next question, which sir has asked, is how to perform the multi-class classification using the SVM. So SBC and new SBC implements the one versus one approach, and linear SBC does the one versus the rest approach. Okay, I'll look into them more, and but for the time being, you can see that SBC and new SBC gets the one versus one approach for multi-class classification, and linear SBC gives the one versus the rest approach for multi-class classification. How? So decision function shape can be either one versus one or one versus the rest. And in case of a linear SBC, multi-class is possible. Okay, so that can be one versus rest or primacy. So there are obvious. With that, we come to the end almost. So we have some advantages of SVM and some disadvantages of SVM. As we know that SVM works with various. I mean, if there are many lines of input, then also SVM works properly. It is an effective in high dimensional space. And after that, we have seen that they are effective in cases where the number of dimension is greater than the number of samples. Okay, it is effective in samples where the number of dimension is greater than the number of samples. And it uses a subset of the training points in the decision function. Okay, so it uses a subset of the training points in the decision function, and that is why it is memory efficient as well. So it is effective in high dimensional space. It is effective in cases where the number of dimension is greater than the number of samples, and it uses a subset of the training points. It is hence it is memory efficient as well. It is versatile. So it is effective. It is memory efficient. It is versatile. These are the advantages of SVM. So for different, how it is versatile? Now for different kernel function, it can be specified for the decision. Okay. So either they are effective in high dimensional space, or they are effective in cases where the number of dimension is greater than the number of samples. It also uses a subset of the training points in the decision function. Hence, it is memory efficient and it is versatile. Why? The different kernel functions can be specified for the decision. These are the advantages. What are the disadvantages? The disadvantages are that SVMs do not provide the probability estimate. They are calculated using the cross validation. Okay. So SVM do not provide the probability estimate, and they are calculated using an effective five-fold cross validation. So we can avoid overfitting in choosing kernel if the number of features is greater than the number of samples. So we have two disadvantages. One is that it does not directly provide probability estimate, and we can avoid overfitting in choosing the kernel function if the number of features is much greater than the number of samples. And with that, we come to the appendix and the conclusion of the of this part of the slides. Okay. Now we will go through the the our collab files. Just 1 minute, huh? Okay, चलो देखते हैं. So we have nonlinear support vector machine classifier here. Okay, we are dealing with the iris classification problem, as we know. Okay, and we have the first part is of course to, you know, to put the data set. We have pandas, and then matplotlib. We have seaborn, numpy, and killer as usual. All these well-known libraries. Sorry. Yes. So we have the classification problem here. Okay. And what we do is we just, yeah. Then we have obviously we import. So you see, we have imported SVC only. Okay. We have not imported linear SVC or new SVC. We just imported SVC here. Huh? And so we do that, and we do the running, and we have read the data set from the iris data set at UCI database. Now in the linear SVM, what you see, I'll go slowly, okay, so that you can take everything. So the first part is to import the basic libraries. Okay, so if you want to import the basic libraries, this is your part. So you have imported pandas, sklearn, you have panda plotting, sklearn pre-processing. Okay, sklearn, we import train test split, everything we do here. Ordinal encoder, okay, everything. Then we at the later stage we import SVC, of course. Then we import confusion matrix and confusion matrix displaying. Then we import classification report. Another thing which is important to import is plot ROC curve. So ROC curve is the ROC curve gives us the training and testing value. Okay, the linear the linear curve which we observe. Okay, so ROC curve is to be imported. We have ROC underscore AUC underscore score. Okay, this also we have to import. So what is this thing? It computes the area under this ROC, which is the receiver operating characteristic curve. Okay, ROC is what? Now, ROC is the receiver operating characteristic curve, right? So what we have is a ROC AUC score. Okay, and it can calculate the area under the receiver operating characteristics from the prediction scores. Okay, and it can be implemented using binary, multi-class, and multi-label classification, but there are some restrictions as you can see here. So what is the what does it do? It computes the receiver under receiver operating characteristic curve. And another thing is what we have is the plot ROC curve. What is plot ROC? Now plot ROC curve is okay. Anyway, it will be removed, but fine. Currently it is not that much used. So you can use different other other class methods. So one is sklearn.matrix ROC curve display, or sklearn.matrix ROC curve display from estimated. So what it does is basically just it plots the receiver operating characteristics. Okay, it plots the receiver operating characteristics, and that you can do with the other. So it will not be implemented in the next version. Okay, so therefore you can use the other variations which are mentioned here. So one is a scalar dot metric dot ROC curve display dot from predictions, or scalar dot metric ROC curve display from estimator. This you can use. So again, we have cross validation score. So what is cross validation score? As we know, the cross validation, it evaluates the score by the cross validation only. Okay, we have some estimators and parameters here. One is the estimator object, which implements the fit. One which is an array, okay, which is the data to fit, and another is also the array, which is the target variable to try to predict. Okay, the default value of cross-val score is none. Okay, and we have plotting confusion matrix. Okay, that is also currently not that much in use, and it will be removed in the next version. Okay, so what are the current updated versions which you can use? So one is confusion matrix display dot from predictions, or confusion matrix display from estimator. Okay. Um, Apart from that, we have stratified shuffle split, which you have imported from sklearn model. And what is sklearn? What is this one? So it provides the train test indices to split the data. Okay, so it provides the indices to split the data, and this validate cross validation object is a merging of stratified keyfold and shuffle split. So this just gives the train test indices for splitting the data. Okay. Then what we do is we go to the column name. We define what are the column names. The first column name is sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. And what is the class? Those are the things which we are required to tell. Then what we do is we read the data set. Okay, we read the data set from the machine learning database. Okay. Now after that, in the linear SVM collab, what we noticed is that the iris, versicolor, and virginic are nonlinear. Okay, so if you plot, you will see. Okay, here versicolor and virginic are nonlinear. Yeah, so you can see here the blue dots are the versicolor, and the orange dots, the you know the orange, the blue squares are the versicolor, and the orange diagonals, those you know dots, they are virginica. Okay, so how do we separate them? Because as you can see that they are pretty non-linear way they are arranged. Okay, so how do we separate them? So that is why what we are telling is that we have in the linear collab, we noticed that these are non-linear. Okay, therefore we are trying to fit this non-linear SVM and check how it classifies the non-linear data. Okay, wait a minute. Now in the linear SVM, we notice that and here we notice that if we put the data in the DF, okay, that the data frame is included, and then we get the indexes for which this seto size there, and then we drop those indexes. Okay, so you can see So we take whatever wherever there is iris setosa, class equals to iris setosa, then we drop them. Okay. So only versicolor and virginica, those are remaining. Okay, fine. There are 100 rows and 5. Now what we do is we perform the plotting. Okay, why do we need this? So that we can show you that this is actually nonlinear. Okay, so fine. We do the plotting. Wait a minute. Okay, so we have the we have the this thing, the graph plotted. Now what we do? We go for binary nonlinear SVM classification. Okay. First target is to separate the input and output features and using iLog. And after that, we do a train test split. Okay. And we print the shape of the training and testing data. Okay. So what is the shape of the training data? We have 75,4 and 75,1. Okay. That is the shape of the training. First one is the shape of the training data. And the next one is the shape of the training labels. So for training labels, the shape is 75,1. And testing labels, for the testing label case, that is 25,1. And of course, for shape of training and testing data will be same. That is 75,4 and 25,4. Okay. That is the X-train shape and X-test shape. And what is train test split? Train test split splits the array of arrays or the matrices into random train and test subject. Then test subset. Okay. So it splits the arrays or matrices into random train and test, and it is a quick utility which you can use for different purposes. Okay, it wraps the input validation and applies to input data into a single call for splitting. So basically, it is used to split the array into random train and test subset. Okay, you can define what is the test size for you. You can do a random state equals to 0, etc. Of course. After that, we define a pipeline. Fine. What is the pipeline? We have scalar and classifier. Okay. What is the classifier that we have gave? RBF is the kernel. And what is the scalar pipeline? What does this mean? This is a mean max scalar stage. Okay. And what is mean max scalar? Mean max scalar is, you can see, that is the command used to transform the features by scaling to a given range. Okay. So if you want to transform the feature values in a given range, then you can use min-max scalar. So it scales and translates each feature to individually such that it is in the given range of the training set. So all the features will be within the training range, that is 0 and 1 only. That is the given min-max scalar. And how do we use min-max scalar? Is that standard calculate with a formula, and we do a scale from the standard form. So you can see the formula in the Colab. X standard equals to x minus x mean, where x is equals to 0, and divided by max of x is equals to 0 minus x mean x is equals to 0. And x scaled is equals to what we saw, x scale equals to x standard into max minus mean plus mean. Okay. Now what we have is we are calculating the cross validation score and the training accuracy from there. We get the training accuracy to be 94.64%. Okay. So we just calculate the cross validation score here. Similarly, what we have here is that we want to visualize the confusion matrix. How do we visualize that? We can see that the we put predict value, which transforms the data and applies the predict with the final estimator. Okay. So first we call transform of each transformer in the pipeline. Transform data are finally passed to the final estimator, which calls the predict method. So the predict is only valid if the final estimator implements predict. Otherwise, it is not valid. Okay. First, we have to transform and apply predict. How do we do that? We call the transform of each transformer in the, and the transform data will be finally passed to the final estimator. It's called the predict method, and it is only valid if the final estimator implements the predict. How do we do that? How do we do that? We can see that we have tick marks and class names, and the confusion matrix here is generated. Okay. So what is the confusion matrix display? Will it be shown here? Confusion matrix. Yes. So confusion matrix display helps us to do a confusion matrix visualization. Okay. How do we do that? We recommend to use scalar.matrix.confusion matrix display from estimator, or scalar.matrix confusion matrix display, sorry, from predictions. Okay. Create a confusion matrix display. So it is basically used to display or for visualization purpose of the confusion matrix. What are the display labels? So they are parameters. Okay, they can be any kind of parameter. They are not, and they have no issue. Confusion matrix. What is confusion matrix? Confusion matrix is an n-dimensional array. Okay, and that we are displaying it with the confusion matrix display. And now what we do is we calculate and we plot it. Then we calculate the confusion matrix. So this is the predicted confusion matrix. Sorry, the confusion matrix of the predict classification. Okay. So we have iris versicolor, iris virginica in the lower side of the true level. In predicted level, we also have versicolor and virginica, right? So if some of the there are 11 versicolor which are true labeled, and they are identified as which are classified as which are versicolor. So 11 flowers are versicolor, exactly. I mean, truly versicolor, and they are predicted as and classified as versicolor only. They are 11. 2 versicolor flowers, they are identified and predicted as virginica, as you can see in the blue region. 0. None of the flowers which are virginica are misclassified as iris as versicolor. And 12 flowers are there which are virginica, and they are correctly classified as virginica. Okay. This is my confusion matrix. Now, what is my classification report? How many people are online? Wanted to know. There are 9 people we can see.
Yeah, I'm Srinivasan. I'm here. Yeah.
Yeah. Hi, sir. Very. Hey, Srinivasan, sir, the thing I was asking. I mean, are you coming to our campus on any information about that?
I have not received any information.
Any invitation? Okay, maybe.
No.
Okay. Yeah. So okay, then. Yeah. I mean, not very formal. But we are thinking of. You are in Chennai, right, sir?
No, I'm in Bangalore, but anyway, I have to make a visit to Chennai, so it's pending for a long time. So this will be a good excuse.
Maybe, sir, 6th March. Yeah. I mean, there is a tentative. Okay. That is a tentative date, and I'm not sure whether we'll get invitation or what will happen. Um, Whether it will happen, that is also not sure. There is a tentative on.
So, uh, yeah, this is Tanvi this side. Actually, I wanted to ask about the online proctored exam, which
Ah,
will be happening on 19th.
yeah.
So, sir, what all we can expect in MLP, sir? Like, do we have to make a whole model and on different, we have to do different things, like whatever we have in our practice
So
assignments, or sorry,
yeah.
practice or
Hmm,
grade assignments. Do we
hmm.
have to will we get something like that, or it will be a completely different scenario?
No. Why it will be different? No,
No,
I
no,
mean,
I
yeah.
mean, no,
It
no.
will be
I
the
mean,
similar thing only.
do we have a compiler in the like we have an MLT? Do we
Hmm.
will we have that such like that compiler, or we have to code in Colab or Jupyter notebooks and do something like
I
that?
think. I think. See. Um. Wait. Actually, I have to check, but I think you will get a collab only. Okay. Either you will get a collab, and then from there we can access that or something like that.
Yeah, so they have mentioned in the discourse, I think Jimmy has mentioned that it will be an assigned collab. So may not be our own
Yeah.
collab, there may be a particular collab that is assigned.
Okay. Also,
And hmm,
will we have just one question over there, one data set like that?
so data set will be different for different people.
No, not like that. I mean, will we have a one particular data set over which we have to perform some 10 or
Yes.
15 tasks like that?
Yes. So
And
one
if
data set. Hmm.
okay, and if we have I mean, if we have one, so we have one data set. So, sir, like, will we have, do we have test cases over there, or we have to just perform the task and make sure the accuracy is maintained, or we are
This
trying
is
to get some
MCQ,
good accuracy
MSQ
out of it?
questions. This is MCQ, MSQ, NAT questions. You have
Okay,
to solve the program on Colab. As far
okay,
as I know, okay. I
okay,
don't know how to. I mean, there are algorithms and machinery to check, but you will
okay,
be given a Colab. You will be given a data set. Okay,
okay,
and
okay.
you have to do basic, say maybe all the things you have to do on that data set only.
So
So
basically,
maybe
you have to create a pipeline and make like you know uh, transform the data, then fit a model, and then something like that, right? With different whatever we have learned. Like,
all week one, whatever there is, say data loading, data pre-processing. Uh, then you have
huh.
week two. So week one to week four, right? That is the syllabus. I
So
think.
your voice is breaking.
Uh,
Uh,
can you hear me?
yeah,
It's
so
clear now, yeah.
Yeah. So you have it is week one to week four, right?
Yes, it is week 1 to week 4. Yeah.
Week one to week four, sir. So I mean all those things basically you will be given a data set and you will be given a collab. Okay. You have to write the collab, write in the collab, and you have to give the sorry, you have to give the answer. Okay, it will be MCQ, MSQ, and not MSQ. Yeah, some MSQ and
okay.
some
So
NATs.
basically, the way we have in our grade assignment, like we have to code it, and to get the
Yeah,
answer from the for the MCQs, we have to code it and get the answers through there.
huh. Yeah. So I mean nothing special. Okay, it's just we also the first time the course is running, so we don't want to like give you more trouble. So please, yeah, it's no
All
normal thing. Just read the question carefully because in
okay.
some questions it is said that reload the data set, and I mean in between the questions. Suppose 1 to 10 you go through with the same data set, and in between you drop some of the columns. Okay, but the next column actually does not include that, does not actually requires that previous dropped column. Okay, so read the question. Sometimes it may ask to reload the data set,
Okay.
which you can just do one line pd dot read csv, right?
Yes, yes.
So that you do, and I think it will be easy, man. I mean, you people got like so high marks in quiz. Huh, I think it'll be easy. Just check.
Okay.
I'm not sure. See, the main problem will be I mean, not problem. The technical aspect will be to check the collapse from our end. Okay.
Okay.
But otherwise, I think it is same. But you have a mock test also, right? This Thursday, starting from Thursday or something. Do we
Yes,
have a mock?
it has been mentioned that there will be a mock test and it is
But it
awaiting.
hasn't been
Yeah.
confirmed.
MLP is already configured. I think. MLP is not. They were telling it is not configured or something. Maybe
Yeah, by the way-
either.
So by the way, what was the average in quiz 1 for
It was
MLP?
quite high. It was quite high. I think more than 90. Not 90. Just wait. I can tell you. It is quite high actually. I mean, we did not expect.
Around 75, 80.
Yeah. I think so. I forgot. Um, yeah. Okay, I'll check. Anyway. So that was the average, I think. Hmm. So you can see, don't and keep the mock test. That will be helpful, and yeah, that will be easier. Okay.
So,
And
and
read the question properly.
And sir, for MLP also we have to make a video, right? Like MLT, we have to make a video.
I am not sure. Just see the guidelines. Okay. I don't think so, but I am not sure. Please read the guidelines. Okay. There
And
may be.
sir, one more thing. What can we expect in MLT, sir? Like they have
MLT I
asked.
can't tell. MLT I have no idea.
Okay, sir. No problem.
Anyway, people who are doing both, just Srinivasan here, just a personal comment. There has been a comment, discussion about what kind of NumPy we need and all that stuff. And Karthik sir had posted a small summary of NumPy concepts that would be useful. So in MLT, I pretty much think it is basically knowing the NumPy tricks and knowing the equation, right? Knowing the actual equation of each of those things, loss, what is the gradient calculation algorithm, and how to translate that into NumPy. So this will be the main part. So you can definitely practice with that. That has been the suggestion in those discourses.
So basically, sir, you are saying that I should focus more on NumPy and all the equations which are being covered in the lectures, right?
Yeah, NumPy is, for me, I definitely find NumPy tricky, right? I always have to do the three things and then get the thing right. I never get it right the first time. So
similar for me, sir. So okay, so basically, you will say you're suggesting me to first go through some NumPy NumPy, NumPy.
he has actually mentioned 4 sections and about 10 concepts. Just be very clear on that.
Basically, I'm sorry. Can you please repeat?
He talked about indexing. How do you stack columns?
Okay.
How do you pick columns? So these things you have to be clear. That's how we will be fast. Otherwise,
like add dummy, like the adding dummy features and
so that has to you have a column stack. No, you should know the exact.
Okay. Thank you so much, sir. Thank you really so much.
Yeah, can you just give me one moment? Just continue the discussion. There is some problem with your question. I'll just check once and just then basically read the whatever is the weekly topic processing and others. That will be helpful enough. Okay. The data loading, then equation, min max scalar. Quick to at least I can tell you. Min max scalar. Then there will be like small RFE. Then there can be what else? Some small pipelines. Okay, 2-step, hardly 1 or 2 steps per way.
So basically, all the stuff all the pre-processing stuff you're suggesting, and as well as I think in the first 4 weeks we have covered linear regression, SGD regression, and a bit of, I guess, polynomial part was also covered here.
Yeah, whatever is the syllabus in week 8 that you can just.
And sir, also the data loading, will it be given by you guys, or the data could be the part of the sklearn data set only, like loading?
No, there is a new data set. There's an
Okay. Okay.
Just give me one moment. I'll get back to you. Okay, 1 minute. There's some issue with your question.
So, Srinivasan sir? Hello?
Yeah, go ahead.
So also, for example, in NumPy, there are many arguments over there, right? Like a lot of there are a lot of arguments. Like everything can be done in 2 or 3 ways, right? So, so do we have to remember everything or?
Yeah. Okay. So I think by practice, right? So I'm just trying to read since sir is also away. I thought we just read the comments from Karthik, right? He said you should know about array manipulation. Yes, everything there are multiple ways of doing it, but whatever is your method, right? Get that. Be very clear about that. See, array manipulation meaning getting the number of dimensions, reshape, which is very important, transpose. So this is the array manipulation part, right? And getting the correct index, right? And how do we specify the index? How do we specify the different features, the different dimensions very clearly? And initializing the arrays, ones and zeros, right? And then getting a summary of the various array parameters like sum, mean, var, std, right? In all this, knowing which axis to use, axis equal to 0 or axis equal to 1, right? And then multiple arrays basically concatenate, column stack, and right, those operations, right? They have v stack, h stack, multiple of them. So, but you have to be clear about which one you use. And then the dot product, right? Either you use dot or you use the at sign, but these are the main things, right? And get another, that is suggestion 1, right? These are the NumPy concepts to learn. Suggestion 2 from, again, I'm just reading from Karthik's email, is to get fluency in converting mathematical equation to NumPy equivalence. So if you get a mathematical equation, you have to be able to write the NumPy, because this is where the trick is, because NumPy operates on vectors, right? So you have to be very clear that you get the vector version and you're able to write a clear, very fast code, right? And
so here by saying mathematical expressions, it could be anything, or they are just saying that
those algorithms, right? Like the last vector.
Yeah, there are like I think 4 or 5
Yeah.
vectors we have.
Yeah, I think either Anand or Jaydev, I think one of them had made a post for the first 4 weeks, right? This is that all the 4.
Yeah, I just saw Anand sir's.
Yeah, so
yeah, Anand Iyer sir.
Yeah, and then the third suggestion is fluency with operations that are directly done on NumPy array. Okay, this is accessing a particular row.
Third one is again. Can you please say?
Fluency with operations that are that directly done on a NumPy array. Right?
Okay.
So
like
this is NumPy manipulation, right? So access a particular row or column, get all data points that belong to a particular class. This is like where you have to use np.where or whatever, right? Be able to speak things, right?
So okay, like also multiple conversions, like np.where.np.where, like that. The multiple.
Yeah. See, even here just now, sir used, right? He used data to get all the classes, all the rows, indexes of all rows that belong to a particular class. Then he used the index to drop those rows.
Yeah, like yeah, got it.
Argmax, argmin, all kinds of this arg functions. So these are the part. This is where the tricky part is, right? If you don't get this, some algorithms you may not get it at all, right? Yeah, but I think maybe suggestion 3 is more useful for later weeks. Weeks 1 to 4, I think suggestion 2 may be good enough.
Yeah, I don't think so. There are many, like only in label encoding part we use the arg function. Otherwise, we don't. I haven't seen. I mean, I don't remember.
Yeah, and another thing I had mentioned, I don't know how many people follow it. Whatever I do is that both the practice assignments and the graded assignments, when I practice things, right? What I do is when I first write the code, I just print the input variables. Okay, all of them, just print the input variables. I copy paste into my notebook, right? Then I write my programs using Collab and with the various input statements, right? That way that you get the sample of data. right? And of course, you can do it for the public test cases. You don't have the private test cases, we can't do it. But that helps me practice.
Okay, so basically you put your own data in.
Yes.
What does it do? Sorry, sir. What does it do? Can you remember?
See, whenever there's a programming question, the first time when I write it, all I do is just print the input parameters, right? Then the output will come, right? It'll say the test case did not pass, but I'll just take copy paste the output and keep it with me. In Colab, I will write the code and then pass these inputs one by one, right? That way, again, when I revise, right, it is very useful because you know what data to give.
Okay. Yeah.
I think Srini sir should take a lecture on how to study.
How to study MLP, is it?
You should
Yeah,
use
actually-
Jaydev. You should use Jaydev's thing. He has done a very good class.
Yeah.
Please attend that Zoom class. You can watch the replay. It is very useful.
You can actually join. I mean, and yeah, once you guys pass, please, you can join as a, volunteering TA and something like that to guide the next batch. That will be very helpful. Thinking that actually. Yeah. So I think Anandaya, of course, is very. He does that. I think he arranges some lectures. So I think so. Have you any of you attended? I don't know. Hello. Am I audible?
Yes, sir.
Yeah, sure. Yeah. So that's what we were thinking. I mean, once you guys finish the course, then you guys are actually welcome to join, and that will be helpful for everyone, and we can you can actually help us to incorporate more new things which are difficult if it is a small team, but if you guys also are helping, it will be very helpful to make the more accessible. Okay, so anyway, we'll show the code as we were. As the collabs are not visible. So so then what we do is we import the we do a plotting on the ROC curve. Okay, and we import the do it by using ROC SVM equals to plot ROC curve, and after that we calculate the area under the curve. Also different. Anyway, so and we can see that this is a very near curve, which it should be. So for or whatever be the value of the false positive rate, the true positive rate always becomes equal to 1 for this classification. Okay? And similarly, if we do a hyperparameter tuning, okay, we can see that if we use a grid search CV using cross validation, then if we just adjust C value and gamma value, we can define the models and we can get a score of 1. The accuracy versus let's see the code again. We do we take standard scalar, and what is the scalar fit? Then we do a fit transform at the extreme and the x-test as well. Then what we do is we define the from -2 to 10. We define the log space at 13 different values, and the gamma range is located at -9 to 3. Then we do this stratified shuffle split, and on this 0.2 test size. Please check the random state as well, because that helps us to get the same result every time. We have a grid search CV with of course kernel. We have taken the regular default kernel only, RBF. Okay? And after that we have done a fitting. Okay, and what is the value score we are getting? We are getting 1. So again, I'm sorry about digressing. So have you guys done any more of the as all of you are most acquainted with these topics, and some people more than us. So have you guys are trying like code in some other languages as well? Python is there, like C++ or are any of you guys doing? Any thoughts on that? Whether we
Sir,
can do that?
I am a statistics major. So
Great, great.
one of my main programming languages taught in the colleges are.
Yeah, yeah. So, are you trying to? I mean, have you tried incorporating these same algorithms in R? Is that
Yeah, sir.
possible?
Sir, actually in R these regression models and everything is pretty direct. You don't have to do much in there. So,
Okay.
so for example, here we have to call it from sklearn and everything, right?
Hmm,
So there are also packages, okay, and you have to call it, and then it's just linreg and it does the best fit for you directly. I mean, it
Okay.
doesn't require much hyperparameter tuning. A few actually.
And so the code is also smaller, I think.
Yeah, the
Shorter.
code is just a one line like a word actually, not even a sentence.
Okay.
It's pretty
And
small, but the accuracy varies a lot in Python and R actually.
sorry.
In the last week only,
Mhm.
I had my final submission of my final project submission. So I coded both on Python and R, and my accuracies which got accepted by the college department were the Python ones, because they told even though the Python one was a bit low, but they were more precise in the sense of actuality.
And is R faster than Python?
I can't hear you, sir.
Is R faster than Python or slower? Is the speed more in any
Hello?
case? Yeah. Can you hear me? Can you hear me now?
No,
We can
actually,
hear
I don't
you.
know. It's very slow for me.
Yeah. Maybe. Yeah. Tanvir, I think my voice is not going to you.
Maybe. Hello?
Okay,
Can you
fine.
please speak? Yeah.
Yeah.
Now I can hear you.
Yeah. No, sorry. I was. I digressed a bit. We were talking that whether application with R, I mean implementation is faster to implement Python.
Yeah, in the sense it is faster because the code lines are pretty much zero, and also in the sense it is pretty much just R is pretty much direct. Like you don't have to put much efforts there. You have to just put it. It's just direct and very less hyperparameter tuning. As of now, I have learned in my last year. So I'm just 3 or 2 months old in R. Not much, but still, it seems there are no hyperparameter tuning. Otherwise, they would have at least mentioned it.
And can anyone comment on C++? Any thoughts?
No,
I have seen C regression only, and it is pretty much there is no packages that much available for it. You have to code it, like no package available.
Yes, Srinivasan sir were talking.
No. All my life I worked in C, so I'm not going back there.
No, not C. Yeah, C++. Actually, someone was telling me that it is much faster than Python.
No.
So,
Yeah, see, once you get the program, but writing the code in C++ will take much longer time.
that is true. That is true. Of course, that is true. Yeah. Okay. Yeah. Okay. So yeah, great. That is great. I mean, we were thinking of trying to do some comparison, and if that is possible, I mean, to implement the same algo on other language.
Yes, C++ obviously because you compile the code, right? And then there is so much of optimization that is done. I used to work on compiler, so I'm kind of very familiar with it. So amount of work we do to make the code faster, right? Those cannot be applied to Python because you don't know what is the next line, right?
Yeah.
So it is an interpreted language, so that it has its limitation. But writing, I think, is Python can't even compare the speed. It's much faster to develop the program in Python than in C++.
Okay, just sorry, another small question. How many of you guys are planning to sit for placement? I mean, maybe next year, I think the placement time will come. Any have you guys planned anything?
Yeah, almost everyone.
Almost everyone.
Yeah, whoever is who are most likely to complete their diplomas by September, right?
Diploma, okay, diploma. No, I mean the degree level is on starting on September, right?
Yeah, that's what, like, I think by September, like, the first batch will be completing the diploma, right?
Mm. No, okay. And the I have to check what is the placement time. So, to see, I mean, is it happening when the diploma is happening or
Diploma is complete, like,
when the
after
diploma
the
is
diploma gets completed, yes.
okay? Okay, yeah, yeah. People here are also, you know, gearing up for the things. Okay, let's see. Yeah, yeah. Surely, many of you will get great jobs. So let us see. I mean, what comes. Anyway, so we plot the accuracy versus hyperparameter here, and you can see the code is given here. Okay, we have the coefficient and the C value is given. I'll just so that you can take a screenshot. Okay, then you do a kernel equals to RTF we plot, and then we have a fitting, and after that we do a metric and accuracy score, etc. And with that we do a plot, semi-log plot. Okay, semi-log plot for both the SCC as well as SCC TR. Okay, which is the which are the variables, which are the values here, the x-axis values, and so SCC is the testing accuracy, and SCC TR is our training accuracy. Okay, and after that we do an X level and Y level, and then yeah. So what we can see is that at 10 to the power minus 3, the value of C, the test, and for all the cases actually, for most of the cases, the training accuracy, which is the green color line, that is higher than the testing accuracy, right? And at 10 to the power minus 3, the value was low. At 0.1, that is 10 to the power minus 1, the testing and training accuracy remains almost same. And after that, it starts to diverge. Okay, as a, I mean, yeah. So we, that is the thing, and then after that we go to the visualization. What we do is we go to changing sepal. We see the what are the training and testing set values. After that, mostly we are just plotting the data for visualization. We take an RDF kernel with gamma value 0.7 and create a mesh plot. And for plotting, we assign a color to each point in the mesh. So what is the plot coming? So you can see that this is a sepal width versus sepal length plot for RBF kernel C value to be 0.1. And if you reduce the C value, then the region is actually increasing. Okay, and if you increase it more, then so what it is doing? Yeah, so if you increase it more, then if you increase the C value more, okay, from 0 C equals to 0.1 to 0.5 to 1 and 5, then the region is also increasing. Okay, so that is the main point here. Okay. And so this is the code. This is the code you can see, and you can take a note maybe. So H is the step size, and C is the regularization parameter. Then we start a for loop, and this VM equals to SPC. We create a mesh, and after that, we do a prediction of XX dot travel and YY dot travel we have. After that, we put the data in a color plot and plot the training points. And as we see, with increase in C, the domain size actually increases. Okay. So after that, what we have is different visualization. Okay. We can put points H equals to 0.02, etc. And we can see that this is the visualization. So we can see the domains. Okay, C equals to 0.1 here, and if we do C equals to 0.5, there is a change in the shape of the curve, and it keeps increasing. Okay. After that, sir comes to multi-class classification. What he does is he uses the two sepal features, that is sepal width and sepal length, for the multi-class classification. He does a training test, train and test split, creates a pipeline. So mean max scalar is there. So obviously for your exam this week, please read these things. What is mean max? What is one hot encoder? Okay. What is mm, anyway? Yeah. mm, Anyway, just take care of those small things. Okay. What is log? Then what is exp1m? Okay. What is how to calculate log function transformer? How to calculate polynomial polynomial feature transformation. Okay, all those small things you can expect in the exam maybe. Then sir has generated the confusion matrix and precision and recall value, etc. Those are decoded, and that much is it mostly. So let us try to figure this multi-class classification. Yeah, we have the sepal features. Then we create a train test split here. And after that, we create a pipeline with a confusion matrix. What is the confusion matrix value? 1500, 074, and 039. Now we calculate the precision score, the score values, precision score, real recall score, and F1. Okay, so what is the precision coming? Not very high. It is 0.82. Recall value is also 0.82%. And one score is also 80. And from classification report also, as we all know, we can get these things. How do you display confusion matrix? This is the code as we are talking about confusion matrix display. Okay, and we evaluate it using cross validation. So yeah, please read about the whatever notes you have taken. Mr. Chandan takes very clear notes.
Hello.
Yeah. Tell me.
Srijit, sorry, sir. Actually, I just wanted to ask. See, just a question of from the last week. Actually, not last. I mean, fifth week logistic regressions. We use sigmoid function, right, in logistic regression in general, right?
Okay.
Yeah,
Yeah.
and I know there are sometimes when we use tan h inverse, hyperbolic tan inverse. So I just wanted to ask, why do we don't use tan h inverse when it's also a bit faster than the sigmoid one? I mean, I feel it is a bit faster. We don't use it. I don't know why.
Why not use tan hyperbolic instead of sigmoid in
Yeah,
logistic regression?
I mean, I had this question like also in the fifth week, but in the fifth week I couldn't attend the.
Okay, can you give me some time? This is
Yeah,
your
sure,
question,
no
right?
problem.
Why we do not use tan? I'm actually noting the hyperbolic function instead of sigmoid. We'll post in the that thing discourse, huh? Instead of sigmoid function in logistic regression, right?
Yeah, thank you so much, sir.
Yeah.
Is tan hyperbolic bound?
Yeah, there is some bounds over it, but still it works fine over there.
Yeah, like see, one major reason like I see sigmoid is you are thrashing between like -1 to +1, right? So sorry, between 0 to 1. Okay.
Even this can be, sir. Tan H inverse is actually a very similar shape to sigmoid function. And actually,
Okay.
tan and sigma has already have a relationship. If you have hyperbolic tan, it is also in the form of e raised to x only. So it can be converted into.
Okay.
Tan hyperbolic -6 equal.
So if you have Desmos now, you can just plot both the curves and see.
can you tell me the function?
So tan hyperbolic inverse
Okay.
x. Sorry, y. In the that will be ulta. It will be
Yeah.
y. And is equal to x. That is equal to x. So that it can plot.
Okay. Yeah.
Yeah. And
Yeah,
now
it
you
is
can
in
plot the sigmoid function. So it is quite similar. And if you
sigmoid
can shift it,
calculable. How do you write sigmoid function? Can you just tell
e
me?
raised to
No, 1 by 1 plus e to the power minus x.
okay, we can do that also. 1
by
plus
1 divided by 1 plus e to the power minus x.
Yeah.
so it overlaps and it can be overlapped, sir.
No, but okay.
But how?
Why negative?
You can take care in tan hyperbolic. It is going at -1, I think. No, that is not a problem for you. It is going at -1, but this is we can bound in 0 to 1 only.
But the question is why you are taking tan hyperbolic? Why?
No, to give it in a horizontal side. He wants to
No,
bound.
but actually, like, see, you are getting a W transpose X plus B, right? That is the activation. Okay. On top of that, you are applying a tan hyperbolic function, right? So it should be ideally it should be X, right?
So you can write
See,
this
what
tan h
is
also.
that
That will
Y
also work.
Tan
Tan h
hyperbolic.
x. Tan h x. Yeah.
tan HX, right. Tan HX. Tan HX.
Yes.
Yes. Okay, perfect. Yeah.
So, I mean, my question is this, Tanvir. In the blue curve, which we have is is 0 to 1, right? But in tan hyperbolic, the main difference is that while we are at 0, I mean, the curve is a little shifted more. Okay, so that won't be a problem for you.
Sir, but we can bring it up. That's what I'm saying. Now it is very easy to manipulate it also.
Correct. Actually, like if you see this tan, okay, go ahead.
No, please tell me. Yeah. Mr. Rajiv, tell me. Yeah, what are you telling?
Yeah, this tan hyperbolic is also used. Like if you see these, I think recurrent neural network, right? That time you use tan hyperbolic. Okay,
I
and
think I have also seen. Yeah.
correct. And in certain cases, like your ReLU works fine. Okay, ReLU works for CNN. So these three activations work together, and in fact, sigmoid has a problem. Sigmoid has a problem because it is not zero centered. See, your center is coming at
Precisely.
0.5.
Yeah.
But Tanvir, see, you can use tan hyperbolic. That is not a problem. But did you try using that and check what is the level of accuracy and stuff like that?
Sir, a level of accuracy, I didn't had a very big data set, but for that also, if you see, the level of accuracy doesn't matter much, but it's a bit faster. It takes lesser time. I mean, I might be wrong also, but when I tried it, I just got I got just my model, by using this activation function, my model was but quicker, like just more quicker than the sigmoid function. So I had a question: why not this?
No, this is a choice actually. Like these activation functions, you can use any of these, tan hyperbolic, sigmoid, or ReLU.
Okay.
But you are saying like, okay, your experience is with tan hyperbolic is faster.
Yeah,
Okay,
I found it tan h to be faster, but I don't know why. Like I didn't know. Like I don't know why.
yeah, but actually, faster is not that criteria. But it has been seen that it works good in case of a RNA networks.
I haven't read it about RNA network yet.
Another case is another difference is in case of sigmoid. What we have here is a very smooth variation. I mean, there is very less variation with one of y with x, right? Whereas in tan hyperbolic we have a much higher variation.
So no,
So if you
that
want to,
you can control with that w term. If you write that wx, right? That you can control, like how steep it will be, or how like whether you need to shift in the right, left. That you can control through the b bias term.
but inherently the blue color line will be showing less variation, right? With variation in x.
Not necessarily. Like you give a value like a 2x 2x.
So like here 2x.
Yes, yes, yes.
Okay. Here
And here
also.
also keep 2. Okay, like yeah, like 10 each, like you are seeing like better.
One major thing about tan hyperbolic is that we have a 0 at the middle. It's an important thing. Here. This is just in between 0 to 1.
Yeah,
This,
and that reason, like sometimes sigmoid doesn't work because it restricts the search in these 4 quadrant.
Hmm, hmm. Okay. Okay. Okay, Tanvir, I'll get back to you. Okay. Let me ask the person who took. Why not you use 10 hyperbolic 10 hyperbolic only, right? Yeah, 10 hyperbolic function instead of sigmoid in logistic regression, right? Yeah. We'll post in discourse. Okay, I'll ask.
Sure, sir.
Yeah, Rajiv.
No. Like what I was telling with that sigmoid, there is a problem that when you search for different W's, right?
Mm-hmm.
So your search will get limited to first and first and third quadrant.
First and third quadrant.
Yeah, you cannot move into second and fourth.
Yeah, here we have an extra quadrant in fourth.
Right.
Third. Yeah, first, second, third, fourth. Okay. Okay. Tanvir, have you checked in internet whether there is any mention about this? Tanvir?
Yes, sir. Sorry.
Yeah, have you checked in net? I mean, is there any paper or any mention about this problem?
Internet there are a lot of they speak about the relationships between TANH and sigmoid function, but I haven't come across as of now that about the speed part. So I might have missed something, but I don't know.
Or maybe that is an area of research which you can pursue.
Maybe.
No, truly. I mean, if it is done, it's good. Yes. So anyway, so that another thing is read some of these data science papers if possible. Okay, and this is not recommended. I mean, not required at this stage, as usually this is just a BSc program. But as all of you are quite interested and quite, expert on the topics, we'd say, then please help some of the research papers also. Maybe in Nature. I was posting in discourse also in that reading club group. So some of the Nature papers in data science, some of the Medium blogs or ACM journal papers, if possible. I'm not telling that you should read or something like that, but if you want to read, it is a good time actually. If you want to maybe pursue more research with IIT later, something like that. Okay. Yeah, please. So those are not after this. There will not be much available in books, right? Now also many things are not available in books. So now it's time to go in. You can go into much more deeper.
Yeah, actually, like what we have what we are learning, like probably like it is pretty much in isolation in the sense, say for example we read one classifier or one regressor, but when you try to solve a problem, right, say for example this recommendation, okay, this recommendation is not simply a classifier, right? There is a regressor, there are classifiers. Okay,
Everything will come together.
correct. So like if you can craft such kind of an example, right, like where you will do a mix and match, because these things I asked like quite sometimes back as well.
I
Okay,
think that is yes. What is your week 12?
week 12, we are
Huh?
in week 8 actually.
No, I mean, I know. Do you know the
Okay,
syllabus for week 12? I think that is coming. That last week sir was telling. I mean, the last week is like basically a full what you are telling, a full program with all the relevant things in it. Okay.
yeah.
So 1 week is on neural networks. Okay. I think that is coming in week 11 around. And after that, week 9 is decision tree. Week 9 is decision tree card. Okay, all those things. Week 10 is bagging boosting. Huh. Week 11 is, I think, some basic of neural network. Week 12 will be a complete, the top to bottom thing. As you were telling, I mean, a project, a program consisting of everything, which we have learned in the past few weeks. Okay.
Yeah,
Just check
but
whether that is one thing.
yeah, but what I was trying to tell, say for example, if you take this recommendation engine, right? Now, say generally, like when you see the recommendation, you like many people try to click on the next, say for example, the first recommendation that it is giving, right? So we generally like now if this is the model, then basically you have a bias. Okay, like always like kind of you are getting more clicks on the first recommendation only. How you can remove this kind of a bias in your model?
Okay.
Okay, and then say for example like how you'll come up with these metrics actually, like precision recall, that we understand. Now say for example you see for a recommendation engine, what will be a good metrics? Okay, and also the connection of these weights with the statistical part. Say for example we are getting these coefficients, right? Now this
Sorry.
we are getting these coefficients, right? Like w. Okay. Now what is the p value of that w? What is the, can we construct a confidence interval on that w? Because w is a random number, right?
Can you do one thing? That is actually a quite good question. Just post us in that forum. We can actually push it to sir. Then I mean, he is currently recording, so he can incorporate those things.
Okay, perfect. So after this
Possible.
OPE exam, like I'll put that thing with some detailed information as well.
You can put now also. I mean, we have a meeting with sir also this week. You can put it, and then I can push it. You see, if possible, put this. Okay, because then you have talked with me now. Then I can immediately know that okay, this is the thing, and we can push it. I can push it.
Okay, perfect.
If possible, do this week. Otherwise, next week is also fine. I mean, whoever
Yeah,
sees it,
because what I was thinking, like if I take this recommendation engine example, right? Like then I'll put some more thoughts into that, and so that like all these things can be addressed together, right? Because otherwise, again, like in a bits of pieces, I'll miss some points or something, that sort of.
Okay, sure. I mean, just I don't know how far we can incorporate. I mean, that depends upon sir's plan. But just send to me, okay? Not me. Just post in discourse and maybe tag me if you are doing in the next week also. Just tag me, huh?
I'll
And
do that.
I'll just push to sir and see. I mean, what is his thoughts? Huh? Then
Perfect.
whatever they decide.
Perfect.
Okay, so we have a short time. We'll finish the activity questions. If you can see, so we have first lecture was on is so there are 18 weeks, 18 minutes of content, I think, this week. So maybe next time we will just shift club with the other weeks somehow. Because yeah. So at first question is on which of the following code will throw an error. So from sklearn import SPC, option B and option D. These two are throwing errors. Which keyword parameter is used? C, as we have seen. Which of the module contains an confusion matrix? From sklearn.matrix, import confusion matrix, right? What does SBC.scores return? Option, okay, this is not written, but option B. So it returns the mean accuracy of the given test data. And what is the output of the following code? I just put it there in the collab, and you can see we have pushed hinge loss and C value to be 100. To overfitting, which can be which of the following values may overcome? If we put C equals to 10 and C equals to 1, that may solve the point of overfitting. Option B and D. Again, question number 6, SVM classifiers do not output the probabilities for each class, which is whether it is true or false. So it is a true statement. And the next question 7, which of the following code may be an alternate way? So option B, that is SVM kernel equals to linear. Here we have just made a pipeline with a scalar, with a standard scalar, and linear SPC with hinge loss and C equals to 1. In option B also, we put a linear kernel and C equals to 1. Yeah. Okay. And option A, question 8 is what is the following code implement? Okay. So just basically you put these things in the collab and run the code, whatever is giving. So it will transform the training data to 3 degree and normalize it using standard scalar and will fit the data. We have degree 3 polynomial features. Obviously, all of you have done it surely. We have C equals to 10 and hinge loss. Question 9 is again a pipeline. Standard scalar, then gamma equals to auto and polynomial kernel. What is the degree for this? So the degree of the kernel function is 3. Okay. What is the default value of regularization? That is C equals to 1. For a SVM model, if Xi is an input impedance with label Yi, then where omega W0 and W are the estimated parameters, then X1 is not a support. Okay, fine. Option B is the correct answer. So you have to complete the statement here. For a support SVM model, if Xi is an input instance with Yi, and Yi is greater, Yi into this term is greater than 1, where these are the estimated parameters, then what is X1? So X1 is not a support vector. Which of the following methods is used? Dot support underscore source, which is option B. Question 13 is also a dot, which is used to get the number of support vectors. Then it is dot n underscore support underscore. Okay. And question 14 answer is RBF, which is the used in the So auto, yeah, as you were telling, the default value of gamma is RBF. And which keyword parameter is used in NPC, new SPC, to set an upper bound? So that is new, yeah, as we have seen in the slides. 4 scatter plots are given here. Which data will be better classified using Gaussian RBF? So that is the, okay, you can see that it is in the center is the one data set and the other data set, I mean, it's a core and shell model kind of structure. Right, so in the core, there are the black data sets and the outside shell is the yellow color data set mostly. So Gaussian RBF we can use to classify it much better. That is the first data. Then the next lecture is min-max scalar. And okay, suppose that we want to classify the MNIST, what will be the missing attributes in the following code snippet? Assume that all the necessary libraries are imported. So we have min-max scalar as a pipeline. Classifier is given, kernel equals to linear and C equals to 1. So the answer is B here. So which will be the missing attribute? The missing attribute is SVC. So yes, of course, SVC is not given here, but is a classifier. But our kernel is linear and C equals to 1 for the SVC classifier. And which of the following parameters control the size? The radial basis, that is the gamma parameter. Similarly, we have to plot this data set. I mean, run this code to understand the output. So for the first case, the MNIST data set, it is coming to be this one, 60,000, 28. So similarly, actually, you can put, okay. Pipe 1 equals to pipeline. We have another pipeline of min-max scalar and SPC, linear kernel, 1C. What will it do? What does this code implement? So it implements it gives the accuracy, right? So okay, we have done a cross-validation score, and with CV equals to 2 value, it gives the accuracy of the training data, which is learned using the linear SVM. Okay, fine. This is option 2. And D is correct. Then we are given a confusion matrix of MNIST dataset. Yeah. The confusion matrix of the MNIST dataset. Click the options. So what are the number of device samples that are misclassified? We have A and D options correct. So 4 samples of digit 4 that are classified as digit 0. 4 are classified as 0. Okay, fine. Yeah. And similarly, 25 samples of digit 3 are also misclassified. Okay, fine. That we have to check and calculate from the SVM. And then fill in the missing attribute, which can be used to classify the data. Scalar. Okay, so what we have to put here? Obviously, kernel equals to RDF, right? So A is the kernel. So kernel, this is the template basically. So what they are trying to do is they are trying to, I mean, make you memorize the template. Okay, the pipeline, min max scalar, then SVC, then inside SVC, what we have to write? Kernel, which is RBF, then comma, and then C. Okay, so that is the questions mostly, activity questions. And we have the practice also, but I think we can keep the practice for the Friday session. Okay, it is already some time is gone. Practice question, okay, let's do one question first. Maybe one or two questions we can do. We have, okay, so we have 2 questions which has come up. One is Tanvir's question, why we do not use tan hyperbolic function instead of sigmoid function in logistic regression. Another is from Mr. Rajiv Banerjee, that will put in the discourse. Okay. Question 1 is the practice question. One is write a function compute score to do the following on the IRIS dataset. Okay. Split the IRIS dataset into train and test set with 70-30 ratio, 0.3. From sklearn thing that import svm.svc and kernel as RBF, regularization parameter 20, gamma equals to auto. Random state is 42. Why is it kept low? So it is kept because for same result every time. And then, okay, so there is a spelling mistake. Train the model using training data and predict the computed model score. And which of the following options is the computed score? So at first we import the NumPy and sklearn using import SVM datasets. Then JSON random seed. Then we load the IRIS dataset and we import train tests. Okay, fine. Then what else we are doing? We are just we see the we do a train test split of the IRIS data and IRIS target set. Okay, so we have done a 70:30 ratio, right? So therefore, what we have is a test size to be equals to 0.3. The compute score, then we calculate the we compute the score here and compute. How do we define the compute score? So model 1 equals to svm.svc. Okay, fine. And this is our kernel, which is equals to RBF, and C is given to be 20, gamma is to be auto, which is defined in the question paper. Okay. So model 1 dot sit and then score 1 equals to dot score value. And if we run the score, run the function, then the score is coming to be 1. Okay. So that is the question, and you have to just maybe mark, yeah, which one is the option? The correct option is option number C, which is 1. Okay. So we'll keep the session up to here. Please, we'll finish the remaining of the practice assignments in the next session. And please, yeah, the question P, okay, the online proctored exam. Yeah, sorry, someone is telling something.
Yeah, sir. Like for that online proctored exam, like do we have a kind of a mock round of that?
There is a mock. There is a mock. I mean, we built a mock. I think tomorrow or today.
Okay.
Have you seen? I mean, either it may be already uploaded.
No.
Just check.
I'm not saying that. Like, say for example, like mock with proctored or something. That kind of things will be there, or you will be uploading some kind of a mock questions and we'll have to go through that. Like even in
So you
such
are
kind of
asking
a
in
session.
mock. You are asking whether in mock there will be proctors. Is that
Correct, because it seems like we need to kind of record a video explaining the code, right? So this will be the
okay?
first
Okay.
time that we will be doing that.
Okay. Let me check the guidelines. Okay.
Okay.
Have you guys received any guidelines like in MLP? You have to
Yes.
receive record the video.
We received the guideline like
Hello.
through an email. Okay, but
Hello.
hello, can you hear me? Hello.
Yeah. Can you hear me now?
Yes.
Yeah. Okay. So I think Shefali ma'am is telling that the announcement was for email only.
Okay. Okay.
I'll just do one thing. I'll ask, and yeah, you can ask in the if any specific guidelines for MLP is there, you will get it. Okay, I'll ask them to send. Okay.
Okay. And
Okay.
secondly, like
Yeah.
another thing on that, like so far, whatever classifier we have been doing, right? Like we have been doing with kind of everyone has a limitation that it can work with a linearly separable data, right? Now with the support vector machine, first time like we came to know about some kernel kind of trick. Okay, but the nonlinear transformation, like we have seen only that polynomial transformation, which can do a kind of transform the features so that it becomes like linearly separable. But it doesn't. Other than that, like can you point us to some other kind of transformation? Because say for example, if the features are not separable in a lower dimension, they might get linearly separable in higher dimension, right? So like is there any other kernels or something that sort of which we can at least read, or maybe like you can upload some kind of a supplement material which will give us some idea like how a linearly not separable data in a two-dimensional space or three-dimensional space can be projected into higher dimension so that it becomes linearly separable.
can a nonlinear separable lower dimension data be projected into higher dimensional space so that it can be linearly separable? That is the question, right?
Correct. Like, what are the different approach to this kind of a problem? See, I can give a small example. Say, for example, if it is there is a XOR function. Okay, XOR function, like, okay, this is not linearly separable. You can give a translation to that z axis to 2 points, like 2 diagonal points, and then it is linearly separable. So your 2-dimensional data will become 3-dimensional data now, and in 3 dimensions they are linearly separable. But what are, like, these may not be the right technique for more than maybe like 4 or 5 dimensions, right? These may not be possible even. Or what are the different other techniques like which can do such kind of a transformation so that it becomes separable?
Lower dimension only. Okay, sure. Let me get back to you then.
Okay.
Which can lower dimension only. Higher dimension.
Yeah, probably in that discourse forum I will write that as well. Okay.
Okay, you are writing? Okay.
Yeah, I am writing that like with some normal text, but probably after the exam I'll put more thoughts on that. Okay.
Okay, sure. Sure, I'll also push the question. I will also get back to you.
Okay.
Yeah. Okay. Thank you. So I think that's very helpful, and yeah, best of luck for all your exams, and yeah, please read the question. I mean, otherwise it is easy. It should be easy. You have come up to week 8. It is from week 1 to 4 only. Should be easy.
Okay, sir.
Yeah. Thank you.
Thank you.